In this video, I would like to go over some simple graphs of sine and cosine from our section 4.5 in our textbook. Alright, well, on the left side over here, I've included the formulas that we are going to use. And also, I've included the graph of a normal cosine wave and a normal sine wave. Okay, well, let's take a look at this first example. Y is equal to 2 sine x. Now, in the context of these equations, let's figure out what this 2 represents. And it's in the position of the A. And the B here, which is the number in front of x, in our case, is equal to 1. Okay, so we have no D and we have no C in this example. Okay, we can begin. So the amplitude is given by this little formula. And so we take the absolute value of A, which is the absolute value of 2, and it's 2. The period, we're going to use this calculation here, 360 over B. Or I can actually use 2 pi over B if I choose to do it in radians. Let me do it in the degrees. So 360 over B, and B is equal to 1 in this case. Alright, so we see that the period is equal to 360. Okay, we are ready to graph. So I am graphing sine x. And so sine x is this equation here, or this graph, that looks like one mountain followed by one valley. So it starts at the origin. Sine starts at the origin, and that's at 0 degrees. And how long is this wave going to be? Well, that is, we know that by the period, and the period is 360 degrees. So I'm just going to come over to the right side and say that this will be the end of the wave, 360. So 360 is going to go there. Okay. Now the middle of the wave is right here, and I'm going to have to, when I do the graph of sine, it'll have to be one mountain followed by one valley, as we can see in this normal graph of sine, one mountain followed by a valley. Now the difference between this problem and this particular graph over here, the normal graph, is that in this example that has an amplitude of of 2, well, the mountain is going to reach all the way to 2 up here, and the valley is going to reach all the way to -2 down here. So okay, we are ready to graph this. So one mountain followed by one valley. Okay, and so when you do this, try to space out everything nicely, and as high as you go, that's how low you're going to go as well, because of the amplitude. And so the other thing that I'm going to ask for you guys to do is to label some of these points on the x-axis, and in particular these key points here, all the intercepts. So we got 0. This would in the middle would be half of 360, which is 180. And then, so these are 3 x-intercepts, and I also want the angle where the highest point happens, and in this case is half of 180, which is 90. And the point, or the angle where the lowest point happens. So how do we find this point? We can find the average of 180 and 360. So if we add those two numbers and divide by 2, we get that this is 270. So these are critical points that I'll be asking for in these graphs. Okay, and so relative to the normal sine wave, this has a higher amplitude, which represents a wave that has twice the strength as this normal one that only goes up to 1. Okay, so that's that example. We're done with that. Let's do another one. Let's do y is equal to cosine of x over 2. All right, so let's start getting the information that we need. Let's start with the amplitude. And the amplitude, in this case, there's no number here, so we're going to say that it's the absolute value of 1, which is 1. And let's find the period. The period is, this time let's use the other formula, the radians, 2 pi over b. So it'll be 2 pi over b, or 2 pi over, let me see, let me take a moment and write down the letters on top here. So a, there's no number, so we can set it, we can interpret that to mean that a is equal to 1, and b, which is the number in front of x, according to this formula, it won't be 2 because this is not 2x. The 2 is at the bottom. So what b is 1/2. That's the coefficient. Okay, so b is 1/2. And the way we simplify this is we take the bottom fraction, we flip it, and multiply. So we get that the period is equal to 4 pi. Okay, there's no D and there's no C, so we are ready to graph now. Okay, so the amplitude, sorry, this is the wave cosine. So cosine, if we look at the normal graph, cosine starts at the highest point. So at 0, the high point here, because the amplitude is 1, will be here. So this cosine wave that sort of reminds me of a bird, the two wings being at the ends here. So the left wing is at the high point of 1, and let's see, 1, 2, 3. Let me say that that's the middle. 1, 2, 3. Let me say that this is the end over here. So the high points are going to be at 1. And the low point the low point of cosine happens at the middle. And it's the same distance as the distance that it goes up is the same distance that it goes down. So we went 1 up for the high points. We're going to go 1 down for the low point. Okay, so we are ready to graph this. The period happens all the way from 0 all the way to 4 pi. That's how long the wave is. And so here we go. Make it curve. Just try to make it as even as you possibly can. And as you can see, it's very, very similar to this normal cosine wave. The only difference is that it goes all the way to 4 pi. The length of each wave is longer. And that is it. Okay, let me do one last example. So let me erase. And let's do example number 3. And let's say that y is equal to negative 2, or sorry, negative, I said negative 2, plus negative, let's make that a negative 3, sine of x. Okay, so let's begin getting the letters here. we're going to graph this equation. And so let's see, the negative 2 here is in the position of the D. A is right here, the number, the coefficient of sine, and B, there's no number there, so we're just going to say that B is equal to 1. Okay, so let's see what's going to happen with this. Let's do the amplitude, which is equal to the absolute value of A. So absolute value of negative 3 is 3. And the period, we're going to do, let's do it in radians again. Let's say that it's 2 pi over B, or 2 pi over 1, because B is 1, so the period is 2 pi. That's how long the wave is. Okay, so let's do this. Now this D, the way that it's going to affect the graph is that it's going to raise the whole graph all the way to 2. Well, actually, because it's negative 2, it's going to actually lower the wave down here. So let me illustrate that. By plotting this dotted line at negative 2. And so this is going to be like the new x-axis. All right, so we are graphing sine. So it's going to start here in the middle. And then this has an amplitude of positive 3. So let me climb up 3. 1, 2, 3. That's the high point. And let me go down 3. 1, 2, 3. That would be the low point. All right, and then let's see, how far to the right are we going to have to go? Well, it depends on the period, and the period is 2 pi. So let me just say that, let me make that pi, and let me make this 2 pi. And yeah, the period is 2 pi, so it's going to have to reach over here. All right, so now this is sine again. So it's typically one mountain followed by one valley. However, because the A is negative, instead of one mountain followed by a valley, it's going to reverse that. What used to be a mountain will now be a valley. And what used to be a valley is now going to be a mountain. So this is always going to happen when we have a negative coefficient here in front of sine or cosine. All right, so this is the middle and this is the end. And instead of going up for the mountain, we're going to go down here. One valley. Instead of, and then like what used to be the valley is now going to be the mountain. And it's going to climb up 3, so all the way here. 1, 2, 3. And that's our mountain. Okay, and the length of the wave again happens to be the period, which is 2 pi. And so the middle point is pi. Half of between 0 and pi is pi over 2. And between pi and 2 pi, if we add them up, 2 pi plus 1 pi is 3 pi. And if divided by 2 is 3 pi over 2. Okay, so that's our wave. Okay, and that is it for simple graphs.